Good morning, ladies and gentlemen. Welcome to this very quick video on where functions meet. In this video, we'll only really be considering the possible intersections between a quadratic and a linear. However, the logic of what we're doing in this video can apply to any pair of graphs. For example, and realistically in year 11, you could be asked to find where a pair of quadratics meet, for example. But the process is exactly the same. Firstly, you should be aware that there are three possible outcomes. There are 2 points of intersection, one repeated point of intersection, or 0 points of intersection. And as you might guess, this relates to the discriminant of the resultant equation between the two. More on that later. So we can do this really just with one example. Let's consider these two examples. These two equations rather. Y equals x squared take 5x minus 6. And y equals 5x take 3. Now, one way to do this is using the graphics calculator, which is a completely legitimate way to do it. So if you're doing this in the calculator, in graph mode, you would put them in there, and then you would hit equals. Oh, my head's in the way. There we go. Hit draw, and it does this to you. If it does that, hit Shift View Window. Shift View Window Standard. Standard gives you a broader range. It should let you see more. If it still doesn't work, hit Zoom Out equals, and you zoom out. Great. Now you've got the intersections in picture. When the intersections are in picture, hit Gsolve INS is intersect. It gives you the first one. That's ugly, and that's ugly. In fact, I can tell you that's negative root 3. You'll get good at picking decimals after you've played with them a bit. And that one's ugly as well, and that's positive root 3. Cool. Now, those are not particularly nice answers, but when we get our answer algebraically, we can get a decimal approximate of the algebraic answer and check with our calculator. So it'll give us a way of checking our answer in a test. Alright, so let's get to this algebraically. Alright, if I told you that y equals a and y equals 7, I'm sure most of you would be very happy to tell me that, well, a must be 7. And good, you'd be absolutely right. If y is the same in both these equations, and we're talking about the same thing, and y is equal to a and y is equal to 7, therefore a must be 7. That's very logical, and that's what's going to help us here. If y is equal to something, and y is equal to something else, they must be the same. So that is where we start solving this equation. Effectively, it's simultaneous equations, but it's already set up for us because they've both isolated y. So therefore, we can write x squared take 5x take 6 equals minus 5x plus 3. Why did I say plus 3? Minus 3. And now we solve. So to solve, we put everything on one side, 0 on the other, and then we treat it like a quadratic, bearing in mind that we have the quadratic formula up our sleeve. So to solve, I'm going to add 5x, and to be cheeky, I'm going to do it at the same time and add 5y. Alright, so we'll have then x squared minus 5x plus 5x is nothing. Minus 6 plus 3 is minus 3 equals 0. Oh, that worked out pretty nicely actually. If we're here, well, we know that we can solve it directly. We add 3 to both sides, so x squared equals 3. We square root both sides, x equals plus or minus root 3. Now, plus or minus root 3, if you're not sure on the calculator, you go menu 1, and then you put square root of 3, and you're thinking, okay, I'm going to meet at 1.73 and negative 1.73, and we actually know from graphing it, that's exactly where these things meet, which is pretty cool. Note, that's the x value. If you're asked for the location where these meet, you'll need to provide a point. A point, remember, has an xy pair. You've just found the x's. So what I would do is I would take each x and sub it into the equation. Y equals minus root 3 minus 3. And y equals minus negative root 3 minus 3, which is y equals... Oh, I'm forgetting the 5. You guys would be yelling at me if I did that in class. There needs to be a 5 there. Minus 5 root 3. and minus 5 times minus root 3, which is the same as positive 5 root 3 minus 3. So we've got negative 5 root 3 minus 3 and positive 5 root 3 minus 3. And I bet if we put them in our calculator, we get the decimal approximate of negative 11.66 and positive 5.66. Now, that noise in the background is the cleaner basically telling me it's time to go because he's about to vacuum. But after you get 0 on its own, at this point here, often there'll be something else happening in this side. You should be able to find the discriminant, and the discriminant will be greater than 0 at this point. Because the discriminant is greater than 0, it tells you that you're going to get 2 points of intersection, and you're looking at this case here. If the discriminant was equal to 0, it'd be this one. If the discriminant was less than 0, it would be that one. Just like we did with quadratics, except now it's a curve touching a line or two curves trying to touch. But same sort of logic, and the discriminant tells us the same pieces of information. All right, thank you very much. This will be a short video. Please bring your notes on class to Friday.